Hello, ladies and gentlemen. Today we are going to talk about our new unit, which is about circles and systems of equations, and systems of inequalities and some other kinds of systems. The newest thing that you'll be learning in this unit is about circles and the equations that cause circles to happen on a graph. You'll also be learning about how to graph some absolute value that you might not have worked with last year, and then talk about putting all of these systems, all of these different types of equations and inequalities together so that you can create some of the inequality systems that you're needing for geometry. I apologize if you can hear my cat. So we're going to start here with section 1, which is about graphing circles. And there are two equations I'm going to show you for circles. The first equation is for a circle with its center at the origin, 0, 0 on the graph. And if a circle has its center at the origin, the equation is pretty simple. It's going to be x squared plus y squared equals r squared. And that r is standing for the radius. The x and the y are just letters. They're x and y coordinates. So really the only defining characteristic, like we've talked about before for circles, is the radius. And if the center is at 0, 0, the radius is all we need. So we've got that x squared plus y squared equals r squared. Notice also that it's not a y equals equation. That's because it's not a function. So circles, if you graph them on a graph, you have a non-function. It doesn't pass the vertical line test, so we can't start them with y equals. Instead, we have to write them this way. Here's a different equation. This is the one we're going to use more often. This is for a circle with a center that's not at the origin. It's at some other point on the graph. And we're going to call that point hk. So h is the x-coordinate, k is the y-coordinate. We've seen that before with vertex form of a quadratic. So if we have a circle with the center at hk, then we're going to use the equation x minus h squared plus y minus k squared equals r squared. And again, that r is for the radius. So as you can imagine, it's pretty similar to the one up above. It's just that we have, let me zoom this in here. It's just that we've got two other numbers here, all right? And these are going to represent the point of the center. Notice also that this has a minus in the formula, which means we're going to have to think about switching the sign of our center so that we get it correct for the formula. And we've done that before, and you'll see this as we go further into today. So here are some examples about finding equations of circles. This one's really straightforward. Find the equation of a circle whose center is 1, 5, and whose radius is 4. So all we need to do is we're going to use this circle equation from hk, and we have our hk. It's 1 is h, 5 is k. So we're just going to use this format, parentheses x minus 1, remember that minus is part of the formula, squared, plus y minus 5 squared equals, and then remember, we don't want just 4 here. We don't want just the radius. We want the radius squared. So we want 16 here. So we've got x minus 1 squared plus y minus 5 squared equals 16. Pardon me, I'm removing my cat from the counter over and over and over as I make this video. So the next one is we want to find the center and radius of the graph, and we've got the equation here. So we're going backwards, and we just want to say, all right, what's the center of this graph, and what is the radius of this graph? Easy peasy. So we'll say here's the center, and the center is the opposite sign, since, again, that minus is in the formula. So the h is 2. And the k is -7. So that circle is centered at 2, -7. And the radius for it is going to be the square root of your r value or r squared value over here. So we're going to take the square root of 64, which of course is 8. So that's how we find the center and radius from an equation that's already set up in hk form. However, we can also find the center and radius of equations in different forms, okay? And we can take other forms of circle equations and turn them into something that we might see. So here's what we need to know. This is sort of the key piece of information for this section. If we want to decide whether an equation denotes a circle, or if we want to find the center and the radius of a non-standard circle equation, we're going to use completing the square. We're going to use completing the square to rewrite the equation in circle form. So we saw completing the square when we talked about parabolas. We're going to bring that back here and we're going to use it again in order to turn these equations that are sometimes not written in a way that we would like, to turn them into that vertex form, or that's not vertex, but that center form, that HK form of a circle equation. The other thing that we need to know in order to make sure something is the equation of a circle is the equation must make mathematical and logical sense. And when it says no imaginary outcomes, that would be something like taking the square root of a negative or some other reason that this equation doesn't make sense. So we're going to go with this first one. Is x squared minus 8x plus y squared minus 10y equals 8 the equation of a circle? Well, we don't know until we put it in HK form. If we can put it in HK form and it looks like the equation of a circle, then it is the equation of a circle. But if it cannot be written in HK form, then it's not the equation of a circle. So we're going to use completing the square here. The first thing we're going to do is we're going to group together the x terms in parentheses. Then we're going to group together the y terms in parentheses. And for each of these, the x terms and for the y terms, we're going to complete the square. We're going to turn this into a perfect square trinomial. So if you remember the method for completing the square, it was when we used b over 2 squared to get to the third number. So we're going to take our b value, negative 8 over 2, and we're going to square that. So negative 8 over 2 is negative 4. Negative 4 squared is 16. We're going to do the same thing for the y's. We're going to take our b value, so negative 10 over 2 squared. That's going to be negative 5 squared, or 25. So to turn these into two perfect square trinomials, we're going to add 16 into the first set of parentheses. So x squared minus 8x plus 16. And I'm going to keep that in parentheses. Plus, and I'm going to take this over here, and we've got the y squared. So y squared minus 10y plus 25. And it's going to equal 8, but remember that we have to keep our equation balanced when we use completing the square. So we also have to say it's 8 plus 16, because we added 16 on the left, plus 25, because we added 25 on the left. So to keep that balanced, we have to add it on both sides of the equal sign. Now we can simplify. So we can turn this perfect square trinomial into factored form. Oh, look, my cat's here. Hi, Mac. And then we can say that that is x minus 4 squared. Remember that we can take that b value over 2 and square it, and that'll be our perfect square trinomial. And then we've got our y minus 5 squared for the same reason. We're just factoring this perfect square trinomial, equals, and then 8 plus 16 plus 25 is going to be 49. And that is indeed the equation of a circle. We can see that we have the x minus h squared plus y minus k squared equals r squared. Everything makes sense. So yes, this is a circle. All right. This next one we look at is x squared plus y minus 4 squared equals negative 25, the equation of a circle. So for this one, this x squared, that's fine. That just means that the x value of our center is 0. We're not subtracting anything from it. So the coordinates of the center would be 0, 4 here. This y section is fine. But then r squared equals negative 25. And I'm sure some of you see what's wrong with that. If r squared equals negative 25, then in order to find the radius, we would have to take the square root of both things. But of course, we can't take the square root of a negative number. It would be imaginary. So this circle doesn't exist in real life. It can't have an area. It can't have a radius. So this equation would not be the equation of a circle. So no, not a circle. So make sure that by the end of your problem, your radius is positive. It doesn't need to be positive at the beginning of the problem, but it does need to be positive at the end. All right. So we're going to switch the page here, and we're going to do one last example. We've got some extensions. So we're going to put this with some of the other stuff we know about circles and work with it all together. So it says find to the nearest tenth the circumference of the circle represented by this equation right here. 3x squared plus 3y squared plus 6x minus 18y equals 15. Mac, can I have my other paper, please? Thank you. All right. So for this one, the first thing I want you to remember is that when we do completing the square, we can't have a number in front of x squared. We can't have a coefficient on x squared. And that works the same way here. We can't use completing the square if we're going to have a number in front of our x squared. So the first thing we want to do is we want to get rid of this number. So we're actually going to take the whole equation and we're going to divide everything by 3. And since it's an equation and we divide both sides by 3, we'll stay balanced. So when I do that, I'm going to come over here. I get x squared plus y squared plus 2x minus 6y equals 5. All right, so I divided everything by 3. And now this is an equation that I can turn into HK form of a circle, and I can then find the center and the radius. So let's see, we're going to do the same process here. Notice that the x squared and the 2x are not next to each other. I'm going to bring them next to each other and rearrange this equation. So I'm going to call that x squared plus 2x, put that in parentheses, plus y squared minus 6y, also in parentheses, equals 5. And I'm going to do the completing the square process to turn this into HK form. So my b value is 2. So 2 over 2 squared, that's 1 squared, which is 1. My b value here is negative 6. So negative 6 over 2 squared is going to be 3 squared, or negative 3 squared, which is 9. And I'm going to turn this into perfect square trinomials. So I've got x squared plus 2x plus 1. And I have y squared minus 6y plus 9 equals 5. And of course, since I added 1 and 9 to the left side, I'm going to add 1 and 9 to the right side. So to simplify this down and factor it, my x squared plus 2x plus 1 factors into x plus 1 squared. My y squared minus 6y plus 9 factors into y minus 3 squared equals 5 plus 1 plus 9, so that's 15. And so we could find the center here. We actually don't need the center of the circle to find its circumference, which is what we were being asked. But if we wanted to, the center is going to be, remember to switch the signs, so the center is negative 1, positive 3, because that formula has that minus in it already. But the radius is the square root of 15. Remember that we want to use the square root of 15 there instead of the number 15, because this number here is r squared already. So to find the radius on its own, we need to take the square root. So after this, we're going to dig way back deep in our brains and find the circumference formula. Remember the circumference formula? Circumference formula is 2 pi r, or pi times diameter if you prefer, but since we're using the radius, we'll use this. So if we plug everything in, which is only one thing to plug in, we've got 2 times pi times the square root of 15. And we could leave it like that if we were asked for an exact answer, but we have been asked to find the answer to the nearest tenth. So if you plug this into your calculator, you will get 24.3, and that's going to be your circumference of this circle. Now, the same process we used here, we can use to find the area of the circle. We can use to find some of the other features and measurements that we've talked about in other parts of this class about circles as well. We don't just need to find the center and the radius. We always can do this extending process and take our thoughts further if we need to. Good luck on your worksheet today. Hopefully you can get through that. If you've got any questions, let me know. Also, if I make any mistakes in these videos, please let me know that as well. It's going to help other people if you point those out to me. Thank you and have a great day.